Alright, so we want to find the vertex and the y-intercepts and the x-intercepts for each of these. And when they're written in standard form, the y-intercept is blatant. Okay, that's the constant number here. Because if we substitute for 0, because we know at the y-intercept that's the x value is 0, we end up with this constant. So the y-intercept, we know, that is equal to negative 16. Okay? And then to find out the x-intercepts, that's when we have y value of 0. So 0 is equal to, and can we factor this? Let's try to do that. Looks like a simple one. So a product of negative 16, okay, that's going to be, what's negative 8 and positive 2. Okay, so our roots are 8 and negative 2, right? So the x-intercepts are negative 2 and 8, okay? So now we got to find the vertex, and in this case we don't have the vertex non-vertex form, so we have to do negative b over 2a, right? Negative b over 2a, that gives us our axis of symmetry, okay? And then we're going to have to substitute the x value to get the y value. Okay, so let's do that. This is for the x value. So negative b, so negative 6, so 6 over 2 times a, 1, so it's over 2. 6 over 2 is equal to 3. So that is the vertex is, well, we got the first part is 3, and then we need to find out what is the y value. So f of 3, let me change colors here. Well, that's fine. F of 3 equals 3 squared is 9 minus 18, because 6 times 3 is 18, minus 16, right? Which is equal to 9 minus 18 is negative 9 minus 16 is negative 25. So that's negative 25. All right, so the vertex is at 3, negative 25. All right, so another one in standard form. So our y-intercept is the constant here. So the y-intercept is equal to 6. X-intercepts is when we have a y value of 0. I'm going to divide everything by negative 2 just to make things a little easier because they're all divisible by 2. So x squared minus 2x minus 3 is equal to 0. Can I factor that? I hope so. So 3 is prime, so it's 1 and 3. So x minus 3 and x plus 1. Oh, good. So the x-intercepts, or the roots, same thing, are what? Negative 1 and 3, okay? And the vertex, well, negative b over 2a would give us the axis of symmetry. So what is that? Negative b, so negative 4 over 2 times negative 2, which is negative 4, so a is equal to, b is equal to 1, or sorry, the axis of symmetry is equal to 1. Now, you know, I didn't have to do that because once I found the roots, I could use symmetry and say, you know what, I know the vertex has the axis of symmetry that's in between the roots, right? Because if I have any graph, and so if I have negative 1 here, that's one value, negative 1, there's one root there. And the other one is at 1, 2, 3 here, okay? The axis of symmetry is here at 1. So I don't always have to just blindly substitute. I can use some of the knowledge I have, understanding of symmetry, okay? So I need to find out what the y value is. In this case, it'll be the maximum, okay? That would be f of 1. So f of 1 is negative 2 times 1 squared plus 4 times 1, plus 6, okay? So that's negative 2 plus 4 plus 6, and that's where we get a maximum of 8, right? So the vertex, in this case, the vertex is at 1, 8. Okay. So now we're looking at another question here that is in vertex form. Oh, nice. So let's start with the vertex for this one. The vertex is 3, 1, because we have h and k. It's written in vertex form, so that gives us the vertex right away. How do I find out, let's see, I think it would be simple to find the y-intercept, because that's when f is f of 0, right? So x is equal to 0. So that's 1/4 times, this becomes -3 squared plus 1. That's 9. So 9/4 plus 4/4, or 1, is 13/4. Okay, so the y-intercept is 13/4. Okay, and then to find out let's see what we can do. See how when we're going to find out the roots, let's use the square root principle, because look at, we've got a perfect square isolated here, right? So that's when we have a y value of 0. So 0 is equal to 1/4 x minus 3 squared plus 1. So then minus 1, right, is equal to, let's see. So I think this is not going to work, right? Because we've got a positive here. So if I multiply by 4, that's still -4 equals, yeah, it's a perfect square, but it's negative. So there's no real roots here. So we're going to say no real roots. If we used another method for, I mean, obviously we're going to get plus or minus the square root when we put the square root in. Yeah, okay. If we use quadratic formula, then you would have the discriminant would be negative, and you'd know there's no real roots. Okay. So let's move on to one more, and I gotta pick some more colors. What other colors are there? Ooh, don't have any more colors. Ink colors. Let's see. Let's go with purple. Okay. So now, again, this one is, well, this is nice because I can find the x-intercepts, or the roots, because they're given to me in factored form. The roots are right there. So 6 and -1. Okay, so those are our x-intercepts. If I want to find the y-intercept, I'm going to make x equal to 0. So let's see what that's equal to. So it's -5 times -6 times 1. Okay, well that's just 30, so equals 30. So the y-intercept is equal to 30. Okay, so put that here. The y-intercept is 30, and the vertex. Eesh. Okay, well, you know what we can do? Let's use the roots, because I've got 6 and -1. So the axis of symmetry is the average of those two, right? So it's actually 2.5. So we know that it's the x value is 2.5. We've got to find the y value. So we've got f of, I'm not going to have much space here. Just a minute. Actually, I can keep going below. So f of 2.5 is equal to -5 times 2.5 minus 6 times, well, this is going to be 3.5. Okay, so we got negative 5 times negative 3.5, right? Times 3.5, which is equal to, get my calculator out. So that is 61.25. Okay, so I don't have a lot of space here, but I'll say the vertex for this one is 2.5. It's positive, right? 2.5 and 61.25. All right. Yeah, you could use negative b over 2a, but, you know, it's not really necessary once we have the roots. It's trying to be efficient as much as you can be.